Hello students, today we start chapter 7 Wave Optics. This chapter carries 7 marks. Before to start chapter, we recall certain terms and laws. Formation of shadow tells you about the propagation of light. That light cannot pass through opaque objects. Also, light travels in straight line, which is called as rectilinear motion. Next, we recall the laws of reflection. To study laws of reflection, we consider a plane reflecting surface XY in which incident ray is incident at the point of incidence and reflected on opposite side of normal. Then the law states that reflected ray lies in the plane of incident ray and normal drawn at a point of incidence, and both incident ray and reflected ray are on either side of normal, and angle of incidence is equal to angle of reflection. Next law, laws of refraction. Consider the incident ray is incident on a glass material at a point of incidence and refracted in another medium. Then, refracted ray lies in the plane formed by incident ray and normal, and incident ray and refracted ray lies in either side of normals. Second, angle of incidence and angle of refractions are related by Snell's law. N1 sin of I is equal to N2 sin of R, where N1 and N2 are the refractive indices of medium first and medium second. Next is the range of frequencies of visible light is from 4 into 10 raised to 14 Hertz to 7.9 into 10 raised to 14 Hertz, and the wavelength ranges from 400 to 700 nanometer. Next is phase at a point. Phase of a point along the path of wave for a particle is its state of vibration or state of oscillation. Consider wave is traveling through a medium, and suppose the position of point is A, then point A represents the phase of a point, which shows the state of vibration or oscillations along the direction of wave. Next is electromagnetic waves. Electromagnetic waves are formed by the acceleration of charged particles and consist of electric and magnetic fields vibrating sinusoidally at right angles to each other and to the direction of propagation of wave. In figure, electric field vector is vibrating along x direction, magnetic field vector is vibrating along y direction, and both the fields are propagating along z direction. These three are mutually perpendicular to each other, and electric field vector and magnetic field vectors are represented by sinusoidal wave functions. Next, light as a wave. We studied the properties of light. Light is an electromagnetic waves. These waves are transverse in nature and consist of small oscillating electric and magnetic fields which are perpendicular to each other and to the direction of propagation of the wave as studied earlier, because light wave is a electromagnetic wave. Next property, light wave does not require any material medium for propagation and can travel through vacuum also. Next point, the speed of light in material medium depends on refractive index of medium, that is, depends on permeability mu and permittivity epsilon of the medium, and we have the relation of velocity of wave in a medium equals to 1 upon square root of mu into epsilon, where mu is permeability of medium and epsilon is permittivity of medium. Refractive index for vacuum is equal to 1 and refractive index for air is nearly equal to 1. Next point, white light is a mixture of waves of different wavelengths, and refractive index of medium depends on the wavelength. These are the certain properties of light. Next, we studied the wave optics. Wave optics is the branch of optics which uses the wave nature of light for the explanation of optical phenomenon. We start the new article, Huygens theory. To study Huygens theory, before that we studied or learned the certain things or certain phenomena. What are the primary sources of light? Primary sources are that sources which emits light of their own due to the high temperature. Primary sources emits their light of their own due to their high temperatures. The example is sun, the stars, flame of any kind, and any heated object at high temperature gives us its own light. Second one, the primary sources again emits light due to the effect of current when passed through them. The example of this is tube light or TV. Also, the primary sources emits their own light due to chemical or nuclear reactions. For example, firecrackers, nuclear energy generators. Primary sources emits or originates in primary sources, light originates in these own sources. Secondary sources of light. These are the sources which do not produce light of their own, but they receive light from some other sources and either reflect or scattered the light around. For example, the moon and the planets do not have their own light, they receive the light from suns and stars. In our daily life, majority sources are secondary sources. Next, most of the secondary sources are extended sources. Next point is phase of the wave. The state of motion of particle at any point as well as the distance of the point from source. Phase of the wave is the state of motion. Phase of the wave, the state of motion of the particle. In figure, A is a state of motion of a particle and from mean position is at a distance x. Means phase of a wave describe point A, its distance from the origin O and its state of motion at point A. When two particles are said to be in phase, that is, have the same phase, when they have the same velocity and displacement perpendicular to the wave surface and they are at same distance from the source. That is, when two particles are traveling through a medium, then these two particles have same velocity and same displacement and which is perpendicular to the wave surface. Next point is wavefront. To study the wavefront, consider the point source H of light which originate the light in all directions in the form of wave. A, B, C, D, E, F, G, H are the some points along which the wave is propagating in all directions. After certain time, if we draw a locus of all points of the medium at which all the points are in the same phase, called as wavefront. Means wavefront is a locus of all points of the medium at which wave reach simultaneously at a given instant. Listen here in figure. All the waves originating from source wave are in phase, means each wave starts from their crest and at certain instant on the surface all these waves are in phase, means all the waves have their crest, means all the points are in the same phase or in phase. We again defined or again said the locus of all points having the same phase at a given instant of time is called a wavefront. Next one is spherical waves. Three-dimensional waves like sound waves, which are produced by the source of sound, or light waves produced by light source, travel in all directions shown in above figure away from the source and propagate in 3 dimensions are called spherical waves. There are different types of wavefronts. First one is spherical wavefront. A wavefront originating from point source of light at finite distance is called spherical wavefront. The example of spherical wavefront is a candle flame which produces the spherical wavefront. It is the surface passing through all the points having same distance from the source and having same phase. In case of light, they are spheres centered on source O. We take here the cross section of the sphere as shown in the figure. The circles in the figure are the cross section of the sphere, spherical wavefront, with source at point O, and the arrows are the spherical and the arrows are perpendicular to the spherical surface. In figure, the wavefront corresponds to the diverging beam of light, that is, the light rays going away from the source. If we want the wavefront corresponding to the converging beam, it produces after passing through a convex lens. To obtain a converging beam, then the wavefront passes through a convex lens, then all rays converges on the focal point of the lens. Next one is a plane wavefront. To study plane wavefront, consider source S. The light is propagating in all directions. Then the spherical wavefronts at larger distance. If we consider a small part of a spherical wavefront at large distance from source, then this wavefront is a straight line and form a plane wavefront. If we take a small portion of a wavefront, it will be a plane surface with direction of propagation again perpendicular to the direction of propagation is perpendicular to the plane surface. In figure, the rays after traversing a large distance becomes parallel, corresponding to the parallel beam of light. Next type of wavefront is cylindrical wavefront. When the source of light is linear or in the form of slit, then we get a cylindrical wavefront. In this, the rays are also perpendicular to the cylindrical surface. Today, we studied light as a wave nature, properties of light. We start again Huygens principle, studied the primary sources of light, secondary sources of light, what is wavefront, what is phase of wave, the different types of wavefronts, spherical wavefront, plane wavefront, and cylindrical wavefronts.